Welcome to video number 5. Those of you who've been with us before, glad to see you. Again, as I say in every time, those of you joining us for the first time, welcome, and do yourself a big favor and go back and watch the first 4 videos in this series. Now, this video series, we say estheticians, but I really wish everybody would watch the videos because the things we talk about are on everyone's test. They're a little bit more heavily tested for estheticians than for cosmetologists or barbers, but they are heavily tested for everyone. Today we're going to talk about chemicals, or chemistry, organic chemistry and inorganic chemistry. Organic chemistry deals with things that are alive or were alive at some point in the past. Inorganic chemistry refers to things that were never alive. Rocks, right? Sand. Organic chemistry, things that are alive or were alive. I mean, we don't think about this very much, but most of your cell phone is made of plastic. Plastic comes from oil. Oil comes from animals and plants that died millions and billions of years ago and decomposed and now is oil. So in a very real, yet kind of strange sense, your cell phone used to be alive. Okay? It's made from oil. Okay? It's organic chemistry. Now, it's very easy to tell the difference in organic and inorganic. Things that are organic will burn. Plastic, rubber. Okay? Things that are inorganic will not burn. You cannot burn sand. You cannot burn water. You cannot burn a rock. You can spread gasoline on it and light the gasoline on fire, but when the gasoline is burnt out, the fire goes out. Organic versus inorganic chemistry. Then there's several terms which are really, I think, confusing, okay, but it's because I have no interest in chemistry beyond passing my test. There's a solution, okay? Solutions are defined as uniform mixtures of 2 or more miscible substances. Solution, a uniform mixture of 2 or more miscible substances. A very fancy word, miscible. M-I-S-C-I-B-L-E, in English, mixable. 2 or more mixable substances. The most obvious answer, example, is coffee and cream. You put the cream in your coffee, you stir it around, they mix together, and they stay that way. Miscible, it's a solution. 2 or more miscible substances. Then you have a suspension. 2 or more substances that do not stay mixed up. We can use our coffee and cream example again. You get your coffee, you put the cream, you stir it around. Then you put the sugar and you stir the sugar around. But what happens if you don't drink it fairly quickly? The sugar settles to the bottom. You have to keep stirring it up every time you drink it. That is called a suspension. It's a mixture of 2 or more things that do not stay mixed. The state uses the word immiscible. I-M-M-I-S-C-I-B-L-E. Miscible versus immiscible. Kind of like possible versus impossible. Right? Miscible versus immiscible. Then you have emulsions. This is a very common thing in our industry. We won't realize it until the test day. Emulsions are a mixture of 2 or more things that ordinarily would never stay mixed up, like the sugar in your coffee, but they're forced to stay mixed up by the addition of a chemical called a binder. Okay? They are forced to stay together. Here's how common this is. Shampoo, all kind of cleansers, okay? Suntan lotion, nail polish. Emulsions are all around you. They are things which ordinarily would not stay mixed up, but they are forced to stay together by the addition of another chemical called a binder or gum. If you look at the ingredients in almost all moisturizers or shampoos, you will see water and at some point oil. And I think you all know water and oil don't stay mixed up. But you don't have to shake the shampoo bottle. You don't have to shake the moisturizer bottle. I'll give you another example. Nail polish. Those of you who have seen old bottles of nail polish know how it tends to separate in time. The chemical forcing things together eventually breaks down, especially from sunlight, and then the oil separates from the color. Emulsions. Mixtures of 2 or more things which ordinarily would never stay mixed up, but are forced to stay together by the addition of another chemical. Then you have what might be their favorite, surfactants. Okay? Surfactants is a molecule with two parts, a head and a tail. It is the underlying chemistry behind every cleaning product on earth. Shampoo, soap, laundry detergent, rug shampoo, dog shampoo, it doesn't make any difference. If it's a cleaning product, it uses a technology called a surfactant. And your state board exam says, which of the following has two molecules, a head and a tail? And the answer is the surfactant molecule. Has two parts, a head and a tail. Now the final thing here is electricity. It's very, very, very short. They will ask you about an electrode, sometimes called a probe. The electrode or the probe is made of glass, plastic, or metal, usually glass or metal. It moves the electrical current from the machine onto the client's skin. Many types of facials require 2 electrodes. Tesla only requires 1. Okay? Now they will have a galvanic current. What is the most common current used in the salon industry? Galvanic current. Okay? Galvanic current is used to create chemical changes in your skin. There's your second question. What type of changes are produced by galvanic current? Chemical changes. Galvanic current is most frequently used in a process called desincrustation. Desincrustation will use mechanical current to create chemical changes in your skin to literally melt the blackheads and the junk in the pores of your skin. It's pretty common to go to a high-end skincare salon. They'll show you a bottle of nice clean water. They run the electrode over your skin slowly for a few minutes with the desincrustation, and suddenly that jar is gray and brown with all the dirt and stuff sucked out of the pores of your skin. That fancy process is called desincrustation. It uses galvanic current. Creates chemical changes in your skin by use of an electrode to transfer the current from the machine to your skin. Now the other one is Tesla current, T-E-S-L-A. Nothing to do with the car. It was a Hungarian scientist 100 years ago named Nikola Tesla who discovered this current and, not surprisingly, named it after himself. Tesla current. On your exam, it is sometimes called Tesla current. It is sometimes called high frequency current. It is often called the violet ray. And those of you who learned about this in school, it uses a glass electrode, and it looks kind of like purple lightning shooting out in a darkened room. Tesla current, high frequency current, violet ray. It's all the same thing. Uses a single glass electrode. Now it is a heat producing current. And there's your principal state board test question. Which of the following currents is a heat producing current? We're going to stop there. Okay? If you have any questions, please give us a call, 760-534-4434 in both English and Spanish. Be sure to get our book. It's a very simple book. It has every question plus the answers asked on your state so far this year. It comes with a money-back guarantee. It comes in an envelope that looks like this from the post office, priority mail. Open this envelope carefully. You might need it. If you fail your test, put the book in the envelope along with the photocopy of your failure notice. Send it back to us with the word refused written in big letters. When the post office sees the word refused, they will take it back for free. If you don't put the word refused, they'll charge you $10.40, so why give them your $10? Write the word refused, send it back to us with the book and a copy of your failure notice, and we will refund your purchase price. You have everything to win, nothing to lose. Give us a call if you want to order, 760-534-4434, or go directly to our website, www.cosmetologystateboardexam.com. On the left side, all the products we offer. Scroll down until you see esthetician, hit the click button, and you're good to go. Thank you, and please give us a call if you have any questions.